I'll be just briefly pointing out why SSL is important. And then I will make a point that most problems with SSL today are usually of our own making. And it's not the protocol vulnerabilities and other things that are important. Actually, what's more important is that we implement SSL well. There's only a bit, just a small bit that you need to know about me. And that's that I'm a compulsive builder. And I tend to get these ideas, and I can't really stop myself from working on them. Some of them turned out all right. I'm probably best known for my work on mod security and web application firewalls in general, although I have recently caught the SSL bug, as you can see from my presentation. And as of a month ago, I work for Qualys and on a new web application firewall, so that will certainly be interesting. Going back to SSL, SSL, as you probably know, is this very nice, very cool communication protocol that can basically be used to take any plain text communication channel, you feed it through the mechanics, to the protocol, the facilities of SSL, and what you get is you get an opaque encrypted data stream, which basically no one can look into, and you're fine, your information is safe and cannot be compromised, and generally the world is a better place. Now, the good thing about SSL is it was designed to work with any other network protocol. And that's also the bad thing. So while this separation of concerns works well for simpler protocols, such as SMTP, IMAP, and similar, what we've seen is it sort of breaks down when you apply it to HTTP, because HTTP and the entire ecosystem, the browsers and the way browsers use SSL, is too complex for SSL. And then we've seen that SSL, it's very easy to compromise it. And this compromise of SSL is actually going to be the primary focus of my talk. So what we had is that SSL was sort of, it came about in 1994, 1995. It was interesting for a while, but then people went on to do other things they considered to be cool and sort of neglected SSL. In the last couple of years, we've seen a revival, and I think it's part of a general trend of back to basics. What we realized is that we haven't done the basics right. And doing SSL right is one of the essential security building blocks. And I think that it's very important to get it right. So in the last couple of years, we've seen very cool and exciting and very technical talks about SSL. We've seen the MD5 collision and rogue CA generation. We've seen null byte attacks last year. And then late in 2009, we saw the most interesting problem of all, which is the authentication gap issue. There are many other smaller issues, and I'm not going to go into detail about them, but I am going to say that all these issues are interesting for security researchers, and they're interesting for people who actually have to implement SSL on a very low level, those who implement SSL libraries. But for normal people, for people who are in charge of maintaining web applications, server deployments, these are not that interesting, because once vendors patch the underlying libraries, the only thing you need to do, basically, is upgrade your software, and then you're done. And actually, you will find that many other problems lie in the areas that are under your direct control. I just wanted to use this photo because Moxie is a very important person when it comes to SSL, because he's done so much over the years to promote and discuss, raise awareness about the insecurities of SSL. So if you want to do a bit of research and see how easy it actually is to defeat SSL in the context of web applications, you can go and find his two tools, which are the SSL strip and SSL sniff tools. And then, once you download them, install them, and compile them, and do everything, and compromise someone in the first 5 minutes of your using the tool, it is the whole gravity of the situation that will sort of hit you. The principal active threats against SSL are these. So I have 5 points here. Obviously, first on the list is the implementation flaws. And it's an obvious one because SSL is implemented usually in C. And there are rife opportunities for errors, and there are errors. But as I said, those things are easy to fix. The next 2 issues are somewhat more difficult to fix. Now, when we speak about SSL, what we normally don't think about is just the protocol itself. Now, the protocol itself is focused on making and creating a very secure communication channel. But it does not work on its own. What you have to do, you have to have like the anchor of trust. And the way we deal with this is we have so-called certificate authorities. And these certificate authorities, they have their certificates. And we decide that we will trust them. So what client browser vendors will do, they will take these anchors of trust and embed them inside browsers. And for all the certificate authorities information that we have inside our browsers, we will trust them. So if you go and open your favorite browser, you will probably see at the moment you have about 300, give or take, certificate authorities. And of those, you probably only need, roughly 10, maybe up to 50. But there's 300 of them, and there are some very obscure names there. And the issue here is that any certificate authority can sign any certificate for any domain name. And this is making many people uncomfortable. For example, there are some claims that some certificate authorities are aligned with foreign governments, or, well, for most of us, there are many foreign governments anyway, because there are so many countries. So it's not entirely clear how safe the entire ecosystem is. And especially then you have the issue of rogue CA certificates. It's enough for any one CA certificate to be compromised that the entire SSL ecosystem goes down. Anyway, security researchers, protocol designers, we will work to fix the issues in SSL, so we'll have to find a way to deal with that. The biggest problems with SSL, in my opinion, are the usability issues, because in the way that end users, normal people who don't deal with security and don't want to deal with security, actually perceive SSL and understand SSL. So if you're a normal user and if you go a website and you receive a warning about something, you're not going to understand what's happening. And I don't think the browser vendors are doing enough to make this process easy. But by far the biggest problem lies in the application and configuration vulnerabilities area, because in web applications there are many ways, many things you can do that completely subvert SSL. And you'll see that in detail further on. Now, I gave you only a few principal threats. And I made an attempt to design the complete SSL threat model. And I'm not going to try to explain it now. I'm just showing you this image to see that there's a great deal of complexity there. If you go to the SSL Labs website, you will be able to download this threat model and look into it. So my view is that you need to be aware of the principal threats, but if you're deploying SSL and you're in charge of either developing or SSL or maintaining service, you have to at least be aware of the various issues that are listed in the threat model. So my way of dealing with the SSL issues is to try to raise the awareness. And I formed a website or organization or whatever you want to call it called SSL Labs, where and on the website I put a bunch of my research. And basically the situation is when I looked into SSL a year and 2 years ago, I realized that there aren't any helpful resources for people who do actually want to understand all the issues. And I basically started to build all the required resources one by one. By far the most popular resource on the website is the SSL server assessment. It's a free online test. It's a very deep and comprehensive test. You can go to the website, enter your domain name, and you can click on that button there. What you have there is a list of recently seen best, recently seen worst websites. And you can let the website tell you how well configured your SSL server is. Now, what I did here, there are three things. One is that there's a methodology behind the assessment, which is fully documented and understands exactly what is looked at and why. The second thing is the important aspect of the methodology is to combine the final score into final result into simple to understand score. So you will get your grade, you will get your numerical score, and for people who are not deeply technical, that's all they need to realize where they stand, and then hopefully make a decision to do one thing or another. And finally, the third aspect is that this assessment is quite deep. So even if you're very technical and want to know a lot about the SSL, there is information there that will go very deep and find specifics about various issues that are possible. Some of the projects that I have on the SSL Labs website. One thing that I forgot to mention is that the important development in the life of SSL Labs is that it has recently been acquired by Qualys. So Qualys is in effect funding all my SSL research. And in the following months, what we will try to do is assemble a community of people, like-minded people, who would like to identify the weaknesses in the SSL and the ecosystem and try to fix them. So you'll just go to a website, see a bunch of these projects, and hopefully you will find them useful. One very interesting project that I'm working on at the moment is a large-scale analysis and assessment of all the SSL servers on the internet. And the idea is that in order to fix problems with SSL, we first have to know how it's used in real life. Anyway, that's been the first half of my presentation, and hopefully you'll find the SSL Labs very useful and practical. And the feature, the important part of this presentation is the 10 most common deployment mistakes. And these are the things that you can fix today or tomorrow. For many of the things on this list, it may require maybe 5 to 10 minutes to fix them. Some of the other issues are not that simple, but I will urge you at the end of this presentation to, when you go back to your work, try to fix at least one of the issues. So all of these 10 issues that I have here basically come from the insight that I got from looking at how people implement and from using the online assessment tool. And interesting enough, so when you open your browser and you want to access a secure website, you will first type the domain name that you want to access. And your browser will then go and try to find out the IP address that's behind the site. And in many cases, if you have a domain name, the inconsistent DNS configuration is a big problem. And you will be surprised as to how many very high-profile websites actually suffer from this problem. If you type a domain name such as www.example.com, it's natural for you to expect, and even more natural for common users, for normal users, that you see the same site as you see on example.com. However, in many cases, you will have very peculiar behavior thrown at you from your browser. For example, the connection was interrupted message. So I've taken liberty to take a high-profile website and look into this is a screenshot of the online assessment tool, which will actually look into the various aspects of DNS resolution. So you will see that Microsoft, for example, they will resolve www.microsoft.com to a single IP address. And you can see that this one IP address has a well-configured SSL server, and that's fine. However, they have two servers for Microsoft.com, and none of them actually respond to SSL. So my recurring theme today will be that in the way we deploy SSL, we constantly confuse our users, and we throw messages